This week we're going to be reviewing fractions. And I want to start by going over how we reduce or simplify fractions. The basic idea is we want to look for a common factor or something that we can divide out of both the numerator and the denominator. In example 1a, I noticed that both 48 and 80 are divisible by 8. So I can start by just canceling out that common factor of 8. But there's more. 6 and 10 are both divisible by 2, so I actually have another common factor. If I divide both 6 and 10 by 2, I'm left with 3/5, and that's my final answer. Now I had to do this problem in 2 steps because I didn't recognize that largest common factor right away. If I had recognized that both 48 and 80 were divisible by 16, I could have divided both numbers by 16 right away and gotten the final answer. But there's absolutely nothing wrong with breaking these problems down into smaller steps. For many people, that's going to be a little bit easier. So example 1b, I need to find something that 51 and 24 are divisible by. I'm not sure about 51, but I know 24 can be divided by 2. Oh, can't divide 51 by 2. Let's see, we could divide 24 by 3. And feel free to check in your calculator, but 51 is actually divisible by 3. 3 times 17 is 51, and 3 times 8 is 24. So I divide out that common factor of 3, and I'm left with 17/8. I can't go any further with this. There aren't any other common factors. So I'm just going to leave my answer like that. Now this happens to be an improper fraction. The numerator is bigger than the denominator. That's perfectly fine. There's nothing wrong with that answer. Now to multiply fractions, we just go straight across. 5 times 4 is 20. 6 times 7 is 42. And then we do always have to reduce our answers. I can definitely divide both of these numbers by 2. And I'm left with 10 over 21. Now, you actually can reduce before you multiply as well. So if you look at that original problem, you might notice before you get started, the 4 and the 6 have a common factor of 2. We can actually cancel out that common factor of 2 and then do the multiplication. 4 divided by 2 is 2, 6 divided by 2 is 3, and now when I go straight across, I'm left with the exact same answer, 10 over 21. It's the same process for example B, except I'm going to rewrite that 24 as 24 over 1. That really helps me see how to multiply straight across. Now, we can always cancel before we multiply, and I think I'm going to do that here because 24 is divisible by 3. 24 divided by 3 is 8. 3 divided by 3 is 1. So 8 times 2 is 16. 16 over 1 is just 16. Now to divide fractions, we're going to take advantage of the fact that division is defined to be multiplying by the reciprocal. So if you want to change a division problem into a multiplication problem, you copy down the first fraction, in my example, 10 over 12. You can change the division to multiplication, and you flip the second fraction, the 1/2, becomes a 2 over 1. Then we can multiply straight across. We could reduce first if we wanted to, or we can just go straight across and then reduce. If I multiply straight across, I get 20 over 12. Both of those numbers are divisible by 4. 20 divided by 4 is 5. 12 divided by 4 is 3. So 5/3. One more division problem. In this last one, I'm going to remember that a whole number 3 is actually 3 over 1. So I keep the 7/10, I change it to multiplication, and I flip the 3 over 1 to a 1/3, and then I can just multiply straight across. I get 7 over 30, and that can't be reduced. That's my final answer. Now to add or subtract fractions, we have to get a common denominator. In example 3a, I already have a common denominator. The denominators are the same. So I just add the numerators. 3 and 2 is 5. And that denominator doesn't change. In this case, we were left with 5/5, or 5 over 5, which simplifies down to 1. Now in example B, the denominators aren't the same. I need to find a least common denominator. In other words, I need to figure out what is divisible by both 9 and 3. In some cases, you'll just be able to think about your times table. What is divisible by both 9 and 3? Well, the answer is 9. So my least common denominator is 9. Now I want both of these fractions to have a denominator of 9. 4/9 already has the 9. To change a 1/3 to a denominator of 9, I'm going to multiply. And the rule is you have to do the same thing to the numerator and the denominator. So the idea is if I want to turn a 3 into a 9, I have to multiply by 3. So I'm going to have to do that to the numerator as well. The reason we do the same thing to the top and the bottom is basically to keep the fraction balanced. In other words, we're actually multiplying by 1, so we're not changing the value of that number. So now I've got 4/9 plus 3/9. I add the numerators. 4 and 3 is 7, and my final answer is 7/9. In example C, we want to add 3/8 with 7/20. To find the LCD, we want to figure out, well, what can I divide by both 8 and 20? If you know what that number is off the top of your head, that's great. If you don't, you can always make factoring trees to find that number. 8 is 4 times 2, and 4 is 2 times 2. That means the prime factors of 8 are 2, 2, 2. 20 is 4 times 5. Again, 4 is 2 times 2. So the prime factors of 20 are 2, 2, and 5. To find the LCD, I start by listing all the factors in that first number. So all the factors of 8 are 2, 2, and 2. And then I move over to the 20 and I write down the factors that are missing. I already have 2 2's written down. I don't need to include them again. But I don't have a 5 written down, and so I'm going to add that in my LCD. 2 times 2 times 2 times 5 is 40, and that's my least common denominator. So back to the original problem. We have 3/8. We need that denominator to be a 40, so we're going to have to multiply by 5. I have to do the same thing to the top and the bottom. For 7/20, I want to change that 20 into a 40. To do so, I would multiply by 2, and once again, I do that to the top and the bottom. That gives me 15/40 plus 14/40, which is 29/40. The exact same process works for subtraction. 4 and 6, what is divisible by both 4 and 6? Well, the answer is 12. So I need to rewrite the problem with denominators of 12. I'll have to multiply the 1/4 by 3 over 3, and the 5/6 by 2 over 2. That gives me 3/12 minus 10/12. 3 minus 10 is -7, so my final answer is -7/12. For my last example, I am subtracting a whole number, so I'm going to remember that that whole number 5 is actually a 5 over 1, and then I can use the same process. In this last example, the least common denominator would be 3, so I'm going to take the 5 over 1 and multiply the top and bottom by 3. That gives me 2/3 minus 15/3. 2 minus 15 is -13, so my final answer is -13/3. Now, if you're asked to write your number or your answer as a mixed number, you can do that with division. 3 goes into 13 4 times. 4 times 3 is 12, so that means 3 goes into 13 4 times with 1 left over, and so I can write that answer as -4 1/3. I could have also thought about mixed numbers when I did the subtraction. If you think about having 5 objects and you take away 2/3, you should be left with 4 1/3. And the answer should be negative because we're subtracting the larger number, subtracting the 5. That's it for my fraction review. As always, let me know if you still have questions about fractions.